We're at the end of FRB 2021, which I hope you agree has been a really interesting conference. I'd like to thank the SOC for all of the work that they've done in terms of selecting the talks, conceiving the format of the conference as well, chairing, dealing with various issues along the way. So thank you very much to the entire SOC, which is listed here on this slide, and really represents a lot of the FRB groups across the world, and theory and observation as well. I feel like in the conference, there's been quite a lot to digest. I've seen a lot of the talks twice, actually, but I think I need to watch them 3 or 4 times to fully digest everything that was said. There's really been a parade of new discoveries and also new puzzles to ponder. And I'm going to mention some observational highlights, but I really wanted to mention as well, I was incredibly impressed by all of the insights that came from talks about modeling, source populations, theory, applications. For instance, like Stella Ocker and Dana Samard gave really interesting talks about propagation effects and what we can do with that. And Amanda Cook as well, very interesting talk about the constraining the halo of our own galaxy. So please don't take offense to the fact that I'm mentioning a number of observational highlights on the next slide. It's also really impressed me how broad the community has become. In the very early days of FRBs, it was kind of some bored pulsar astronomers looking for an interesting diversion, and now we have a really very broad set of skills spanning all of astrophysics, and that's one of the things that I find most rewarding about FRBs, is that it's touching on many astrophysical questions at this point. Don't worry, the YouTube channel will be up for a while, and there's thankfully an entire year until the next conference, FRB 2022, which will be in Busan, Korea. And there's about 35 hours of talks to watch. That's unique talks. That's not including the A and B sessions. And for the speakers, just so you know, given the 2 sessions and all of the views on YouTube, some of the sessions have almost 200 views at this point. I'm pretty sure that most of the talks have been viewed more than 200 times. So that's really quite impressive. Let me check the chat to make sure that something isn't going awry. Nope, it doesn't seem like anything's on fire. That's good. So Slack will remain up. There's some discussion ongoing already about whether we should maybe pay for a professional account to enhance the features there. And it sounds like there's a desire to keep that as a forum for us as a community worldwide to continue to discuss FRBs. And like I said, the YouTube channel will stay up as well. Here are some of the observational highlights that I picked out that I found quite shocking and interesting during the conference. Really, the CHIME FRB catalog is serving as a treasure chest for a variety of studies, and I've listed some of the talks that discuss the applications thereof, including Liam's talk in the late breaking news as well. It was very interesting. Mohit presented this incredible work that he's been doing to characterize the local population of FRBs, which would be great for multi-wavelength follow-up. We saw a nice talk by Kenzie about micro and nanostructure and some repeating FRBs. Daniele McKeely showed an incredibly bizarre burst from one apparently one-off FRB, showing what very convincingly looks like periodic structure in one burst, lasting for about 3 seconds with period of about 200 milliseconds. It seems to me like that must be some different beast, but we'll see. Time will tell. Ziggy Pleunis showed dozens of new repeaters, which is going to be, again, a treasure chest for follow-up studies. Both Natasha Hurley-Walker and Kaustubh Roshwari presented ultra-long period magnetar candidates. And yeah, in the context of various FRB models, it would be very interesting to see whether these can be shown to be sources of very bright coherent radio bursts that could be visible from extragalactic distances. We'll have to see. We saw the localization of one nearby FRB in M81, originally found by CHIME and published in Mohit's paper. That's been now localized to very close to the exact core of a globular cluster nearby. Great talks about statistical studies now of populations of localized fast radio bursts. Hosts were using a couple dozen very precise arcsecond localizations. We have the host galaxies, and we can start studying what that looks like statistically. Dee just presented in this session what looks like an FRB 121102 first repeater twin, which is great to see that that's potentially no longer a strange oddball source, that there's at least one other example in the universe. Maybe not surprising that it's not the only source in the universe that looks like that, but now at least we here on Earth know about two. And yeah, and also Praveer's talk that we just saw about generalized Faraday rotation is great. That we're going beyond the simple propagation effects that we can measure with FRBs. So I think it's clear that FRBs have a very bright future. I probably don't need to convince this audience that that's true, including the high event rate. Really all of these different propagation effects provide fantastic tools. So I won't belabor the point. I'll just mention that, and this has come up many times during the conference, there's a wealth of science going on right now and a huge number of papers that are being published on the population we can detect right now. But I think in terms of exploring the parameter space that's out there, we've really just scratched the surface. And we saw, when we went from, using Parkes to detect FRBs, when Parkes was the premier FRB machine in the world, to CHIME, not only did we get a huge number of sources, orders of magnitude more sources, but we also, because of that orders of magnitude increase of probing that volume of the parameter space, you start to find the things that are even more rare than the FRBs that we used to know and love. So we're starting to find new types of sources, I think, probably. And if you think about going from just having a chime to maybe someday having a gong, which is much more powerful than a chime, obviously, in terms of really maximizing field of view, all sky, maybe with the sensitivity of SKA2 or something like that, and in a decade or two, we can imagine what fantastic beasts there might be to find. Currently, we're just searching a very narrow region of this parameter space, as I keep saying, both in terms of radio frequency and time scales. So we saw a number of talks that I think really clarify that there's potentially an interesting population of ultra-fast radio bursts, and conversely, because it's not so easy to do that in our current searches, perhaps also a population of not-so-fast radio bursts as well. So I encourage you to use these terrible acronyms when talking about this. We still don't know what FRBs are, but I think compared to last year, I would say, oh, and Emily is saying or chord. Yes, you could also call it chord instead of gong. I think, compared to last year, where I was tending more towards the, Occam's razor solution of they're all similar types of neutron stars, I think now I'm tending more towards maybe we've really underestimated what neutron stars can do, and maybe we've also underestimated how many different types of things can produce short coherent radio bursts. So this is a rogues gallery of proposed models, also some not proposed models you can see here as well. I think there's really an avenue for the possibility that as we continue to explore the parameter space, it will really realize that there are distinct types of sources. And hopefully we'll be able to do that someday with large samples that allow us to show, concentrations of sources in various parts of some multidimensional parameter space. So we've seen plots like this a number of times during the conference, and this plot is starting to get filled in. But I would like to end the conference by, emphasizing the point that the first dot on this phase-space diagram of millisecond/microsecond transients was made when Jocelyn discovered the first signal from the first radio pulsar, and I thought it would be really fitting to conclude the conference by giving Jocelyn the chance to give some reflections and some thoughts about that. So I'll stop sharing my screen, and I'll also turn off my video and hand things over to you, Jocelyn.
Thank you very much. Am I heard?
Yes, we can hear you loud and clear.
Brilliant. You don't need to see much. It's okay. Thank you very much to the organizers and the speakers and the chairs. This has been an extremely stimulating and interesting meeting. The field is clearly moving very fast, and we couldn't really have delayed because of the pandemic until we could hold a face-to-face meeting. Thanks also to the organizers for some very ingenious timetabling, which has enabled many of us to listen to most of the talks at a more or less civilized time, and yet be a sort of global conference. There have been an impressive number of new results presented, The field's clearly moving very fast, and for that reason also, it was right not to delay. I've been particularly excited by the fast radio burst field, as I'd been saying to people for a long time, we're neglecting the time domain, we're neglecting the time domain. We should be watching the time domain. And then boom, bang, in come FRBs. I've also incidentally been saying, reminding electromagnetic astronomers about the importance and potential of gravitational wave astronomy, astrophysics. And that too is beginning to deliver in an interesting way. So in addition to further developing time domain, further developing gravitational wave astrophysics, I'd say keep an eye on the astroparticle field, keep an eye on the very high energy gamma ray field, and of course, keep an eye on the gravitational wave field, as there's going to be interesting stuff coming in there, and it may well relate to the time domain stuff. Meanwhile, I look forward very much to the next major FRB conference in 2022, alongside the IAU meeting in Busan in South Korea. Thanks again to all the organizers and speakers, and on behalf of everybody, some applause for you. Thank you, everybody, and keep safe.